Welcome to Maths for All. I'm Aisling Flynn. This is the Circle 1.4, Tangents. So tangents. A tangent is a line that touches a circle at one point only. So in the diagram here we see a circle with centre O, and we see a line that goes from B to C, and it touches the circle at one point only. That's the point A. The radius to the point of contact A is always at right angles to the tangent. That is, the radius is perpendicular to the tangent, and that is always the case. Okay, if we choose a different point of contact for a tangent over here and sketch a tangent which touches the point at one, or the circle at one point only, this is what we call the point of contact. Let's call our tangent T. Well, the radius to that point of contact, of course I could have drawn it much better, so this radius is always at 90 degrees, or always perpendicular to the tangent. Okay, that's a very useful piece of information, especially as we know about perpendicular slopes. Let's remind ourselves of that before we get into any practice. Perpendicular slopes, okay, of two lines are perpendicular if, when you multiply the slopes of both, so m1 times m2, if you get an answer of -1. Okay, and what would they look like? I'll just give a couple of examples. So let's say m1 is 2/3, 2/3, and m2 would be the exact opposite, so plus, instead of plus you'd have a minus slope, a negative slope. Instead of 2/3 you'd have 3/2, and when you multiply those, if you wanted to check top by top, you get -6, bottom by bottom, over 6, which is -1. So they're perpendicular slopes. Okay, this lesson proceeds by working through a question which shows you all about tangents. So the question begins. The circle C has equation x plus 2 squared plus y minus 3 squared equals 100. Write down the coordinates of A, the centre of C, and then write down R, the length of the radius of C. So this question builds on previous lessons. Okay, so we've learned that the equation of a circle takes this form: x minus h squared plus y minus k squared equals to r squared. That's in your formula and tables books, page 19, and it describes a circle that has the centre of hk and a radius r. Okay, now by direct comparison to the equation given, we can see, well, what takes the place of h and of k? Now in the place of h we see a 2, but we see that the minus in the formula has changed to a plus. So what must have resulted in that would be that there was an x minus -2, give the plus. So h is -2. So the x coordinate of A is -2, and in direct comparison 3 takes the place of k, which is the y coordinate, so 3. So -2, 3 is point A, the centre of the circle. Okay, so this is what the circle would look like. There's our centre A, okay, with -2, 3, and we also have to write down the radius, which, or r, which is the length of the radius of C. Okay, so by comparison again, r squared, which is here, is equal to 100. That means r is the square root of that, and of course the square root of 100 is 10. Okay, and we can write that answer in, and just to see what that looks like, yes, the radius of the circle is 10. If you look along here, we're going from -2 back to -12. That's a difference of 10. Okay, so there's our circle. let's go on to the next part now and how tangents are involved. Okay, firstly we have to show that the point P, which is minus 8, 11, is on the circle C. So again, in previous lessons we learned that if a point is on the circle C, well then it should satisfy the equation of the circle and it should make x equal, or left equals to right. Okay, so I'm going to take the equation of the circle from the previous slide. Okay, what we're going to do is we're going to replace x with minus 8 and y with 11, and we'll see is left equal to right, and we expect that it will be because we're given the instruction to show. Okay, so here we go, minus 8 plus 2 to be squared plus 11 minus 3 to be squared, is it equal to 100? Well, let's work it out. We'll get minus 6 here to be squared plus 8 here to be squared. I'll get 36 plus 64, which is equal to 100, isn't it? So we get 100 equals to 100. So there, and we'll write our conclusion. P is on the circle C. Okay, so let's see what that looks like. Yes, so P is minus 8. So minus 8, 11. So you can see the point P is there. Okay, next we're asked to find the slope of the radius AP. Okay, so this is building towards a tangent. So A was the center, recall, and P we've just looked at. Okay, and the radius is there's that dark grey arrow, and we have to find its slope. Okay, so we have a number of ways of getting slope. We can use our formula from the Formula and Tables book on page 18. Okay, or we can use rise over run. Alright, so if we use rise over run, I have to draw a right angle triangle from A to P, or P to A, right, to look at the horizontal and the vertical difference. Okay, firstly, as you go from left to right, from P to A, we drop. Okay, we're decreasing, so we'll have a negative slope, and we fall from 11 down to 3, so we fall 8. Okay, so minus 8 is my rise, that's the vertical, and my run is we go from minus 8 to minus 2, so we run across there, we run across 6 units. Okay, so we have a negative slope. We can simplify this. 2 is a common factor to top and bottom, so the slope there is minus 4 over 3. Okay, so that's part 1. Now, part 2, hence. So this word means use what you've just done or just seen. Okay, find the equation of T, the tangent to C at P. Okay, so the word equation is used, so that means we're looking for the equation of a line. A tangent is a line after all, and from page 18 you'll get the equation of a line formula, which is m times x minus x1. That's it there. Okay, now to find the equation of T, we need a point on T, which is P. That'll be minus 8, 11, but we also need the slope of T, and we've learned that the slope of a tangent is perpendicular to the radius, to the point of contact. So that's where point 1 leads into, or part 1 leads into part 2, and that's the reason for this line, or this word hence. Okay, so the perpendicular slope to minus 4 over 3 will be the exact opposite, so upside down and inside out. So minus changes to plus, and 4 over 3 changes to 3 over 4. Okay, now we can go ahead with our equation of the line. So y minus 11 equals 3 over 4 times x minus 8. Okay, so we can multiply both sides by 4. The reason for that is that 4 divided by 4 is 1 and we no longer see a denominator. Okay, so we'll have 4 by y minus 11 equals to 3 times, now x minus 8, we'll have x plus 8 within that bracket. Okay, moving to the right here, multiply your brackets, we get 4y minus 44 equals to 3x plus 24. I think we'll go with the representation of ax plus by plus c equals 0, so this form of a line. I'm going to move everything from the left over. So we'll take 4y from both sides. We'll add 44 to both sides. Now what will that look like without all the scribbles? We'll have nothing on the left hand side. We'll have 3x minus 4y, and the numbers you'd have plus 24 plus 44. And finally, we'll just tidy up the numbers. 3x minus 4y plus 68 equals 0, and that's the equation of t, the tangent. Now what does that look like on the graph? There it is, that blue line. That's our tangent t. Okay, and it has a positive slope of 3 over 4, and it touches the circle at one point, which is P, and its slope is perpendicular to the slope of the radius. So part C says a second line K is a tangent to C at the point Q, and K is parallel to T. Find the coordinates of Q. Alright, so a bit to take in there. How can it be? So let's do a little sketch here. We had a circle, right? We had tangent T, which touches at P, and now they're telling us that there's another tangent that's parallel. So if you were to lay your ruler down along this tangent T and to slide it down along at the same, keeping the same slope, you would find that there exists a second tangent that's parallel to it, and it would be straight across from it, from T, and it would have the same slope, and the point of contact here we're told is Q. That's what we're looking for. Okay, so we have to find point Q. Alright, let's look at our graph from the previous slide. Okay, we had the tangent T, we have the point P, we have the center of the circle. Now how are we going to find point Q? Alright, so the blue tangent we learned is perpendicular to that grey radius. Okay, so the red tangent should also be perpendicular to it. Okay, if we extend that radius, okay, the second radius from A to Q that we've drawn should also be perpendicular to our new tangent. Okay, so the two grey arrows should be collinear, or in one line, and they should be of the same slope. So we're going to solve this by translations. Okay, now what does that mean? Translation is a sliding movement. Okay, so it's a movement across the graph. We're going to see how do you get from point P to point A. Okay, we're going to examine that. So how far, in what direction, and then we're going to repeat that from A to Q. So same distance, same direction, and that will give us point Q. Okay, so we're first going to look at that movement from P to A. That's called the translation PA. And we're going to examine the coordinates. So if we look at the x coordinates, which describe the horizontal movement, we go from -8 to -2. Okay, so we've moved right 6 units. So from -8 to -2, we move right 6 units. So the x value was increased by 6. Alright, and to go from P to A, let's look at the vertical movements. Alright, so we're starting at 11 and we're dropping to 3. So we drop from 11 to 3, and that's a drop of 8. Okay, so we saw this with the slope. So the y value decreases by 8. Okay, now we're going to, as I said, repeat that movement, and we're going to translate the point A to the point Q. So repeating that same movement. So we're starting at point A, if you recall, is minus 2, 3. So we'll have to take the x value, minus 2, and we have to increase it by 6. Minus 2 plus 6 equals plus 4. Okay. And then we're going to take the y value, 3, and we're going to decrease it by 8, which gives me minus 5. And those two answers there give me the coordinates of Q, which are 4 minus 5. Alright, and you can see the red tangent there touching at Q is parallel to the blue tangent T. Now you can try some work on tangents with your exercises on 1.4.